Hello students, we are going to continue with the equation of straight line, and today's topic is numericals based on normal form. Now before starting the normal form, means this sum, first you note it down two formulas which you are going to apply in this sum, and the formulas are of class 11 trigonometry chapter called compound angle. So this chapter you will read in class 11 only, and we are going to use this formula in this sum, right? So you note down the formula first before starting the sum. So here you can see it is cos a minus b. So what is the formula of cos a minus b? You note down cos a into cos b plus sin a into sin b. This is the formula of cos a minus b. Got it? Cos a into cos b plus sin a into sin b. Now if it is cos a plus b, then it would have been cos a into cos b minus sin a into sin b. If it is minus cos a minus b, so here the plus sign will be minus, right? And you take down one more formula, that is sin a minus b. Sin a minus b, the formula is sin a into cos b minus cos a into sin b. And if it would have been sin a plus b, then here this minus will be plus. Understood? Sin into cos b plus cos a into sin b. Got it? So remember this formula, we are going to use it. Now see the sum. Now the question is, find the equation of the line whose perpendicular distance from the origin is 4 unit and the angle which the normal makes with the positive direction of x-axis is 15. Now in the normal form, now the question, by seeing the question only you can understand that this question belongs to normal form, because here the perpendicular distance from origin, that is p, is given, right? And the angle which the normal makes, that is omega with the positive direction of x-axis, is given. So omega is 15 degree given here in the question, and p is 4 unit. Now students, we have already derived the equation in normal form. What is that? It is x cos omega plus y sin omega is equal to p. This formula we have derived. When we have you refer the derivation of normal form, I have already derived. You check from where this formula is coming. So for the sum, you use the formula directly. The formula of normal form is, how you will understand that this question is of normal form? By seeing that perpendicular distance p is given and the angle which the perpendicular is making with the positive direction of the x-axis, that is omega, is given. By seeing these two conditions, you have to understand that this is a question of normal form. And you see the derivation, you will understand in the last video I have done. You see that video, you will understand how this formula came. So the formula of normal form, equation in normal form, is x cos omega plus y sin omega is equal to p. Got it? So we need cos omega, we need sin omega, and we have p, we know it. So we only have to find the value of cos omega and sin omega and put the values of cos omega, sin omega and p in this required equation. You will get your respective answer. So first we have to find the cos omega, right? So cos omega, so cos, now what is omega for our sum? It is 15, so cos 15. Getting my point? Now see students, how you don't know the value of cos 15, right? You know the value of cos 30, you know the value of cos 45, 60, but you don't know 15. So for these type of things we will take the help of this compound angle formula. So this 15 can be written as cos 45 minus 30. Are you getting? Because both 45 and 30, these values you know. So use these two value to get this unknown value. So cos 15 can be written as cos 45 minus 30. Getting my point? So it is cos A minus B. This format. What is the formula is saying? Cos A minus B. It is cos A cos B plus sin A sin B. So use it here. So cos A minus B, formula is cos A. So cos A, what is A? A is 45 dot cos B, what is B? 30. So cos 30 plus sin A. So sin, what is A? 45. dot sine b. So sine, what is b? 30. So this is the formula of cos a minus b. We are using this formula for cos a minus b over here. Now you know the values, all the values you know. So cos 45 is what? 1 by root 2 dot, right? Cos 45, you know it from class 9 as well as 10. So cos 45 is 1 by root 2 dot cos 30 is root 3 by 2 plus sine 45 is again your 1 by root 2 dot sine 30 is again half. Now see, you multiply this 2 into root 2, it will give you 2 root 2 in the denominator, and root 3 into 1 is root 3 there. So root 3 by 2 root 2 plus similarly 1 into 1 is 1 and 2 into root 2 is 2 root 2. Now see, you can do LCM. So 2 root 2, 2 root 2, 2 root 2 LCM. So when you will see with 2 root 2, this 2 root 2, this root 3 will be multiplied by 1. Right, so root 3 into 1, that is root 3 only, plus again when you will see this 2 root 2 with this, so this 1 will be multiplied by 1, so it will be 1 only. So in the denominator, in the numerator, you will get root 3 plus 1 by 2 root 2. Now we have got the value of cos omega. What is it? It is root 3 plus 1 by 2 root 2. Now similarly, you need the value of sine omega. Now sine omega is also what? Sine omega is what? 15. It is given in the question. So sine 15. So in the similar manner, you can write sine 15 as sine 45 minus 30, because you are using the known value to get this unknown value. Sine 45 minus 13, the difference gives you 15, right? So now again this comes a sine a minus b formula. So what does sine a minus b is saying? Sine a into cos b minus cos a into sine b. So sine a, what is a here? 45 dot cos b. See the formula? What is b? 30 cos 30 minus cos a. What is a? 45 dot sine b. What is b? Sine 30. Getting my point? We are using this formula. Now all the values you know, put it. Sine 45 is 1 by root 2 dot cos 30 is root 3 by 2 minus cos 45 is again 1 by root 2 dot sine 30 is half. So again you will get 2 root 2 in the denominator and root 3 here, minus 2 root 2 in the denominator, minus 1. So again by taking LCM, your LCM will be 2 root 2 only. So this will be root 3 minus 1, right? So 2 root 2, when you will see this 2 root 2 with 2 root 2, 1 you will get. So 1 into root 3 is root 3 minus again you will get 1. So 1 into 1 is 1. So this you will get root 3 minus 1 by 2 root 2. So we have got the values of our sine omega and cos omega. Substitute the value of sine omega in our sine omega and cos omega and the p in our respective equation of normal. See, this is the respective equation of normal. In this equation, substitute all the values of p which is given, sine omega, cos omega, which you have calculated. So sine omega, put the value. So cos omega, we have got root 3 plus 1 by 2 root 2, right? X will be x only, plus, because it's an equation we are forming, so x and y will be there, just we will be substituting the value of cos omega, sine omega. So sine omega, we have got root 3 minus 1 by 2 root 2 y is equal to 4. Now again you can take LCM. See, 2 root 2 is the LCM from these two cases. So 2 root 2, again this root 3 plus 1 will be multiplied by 1 only, right? So root 3 plus 1 x, plus when you will see this 2 root 2, with this 2 root 2 again 1 will be multiplied with this. So root 3 minus 1 into y, right, is equal to 4. Now you bring this 2 root 2 over there. So your required equation is root 3 plus 1x plus root 3 minus 1y equal to 4 into 2 root 2. So 4 2s are 8. 8 root 2 is the required equation of normal. So students, keep practicing. Thanks for watching. This is Shagnik sir.